In this video, I would like to look at some practical examples. Um, so these examples focus on laws of indices and exponents or exponents. I have three examples here. The very first example is basically just numbers, and we are trying to manipulate, um, we're trying to simplify it as much as possible. The other two numbers have some symbols. So let's see how we can use the laws of indices to deal with these three problems. Okay, example one. How can we simplify this expression here? We have two fractions. So the first the very first fraction is raised to 2/3. The next fraction is raised to minus 2/3. So the exponent are somewhat similar. They only differ by a minus sign. So what can we do here? So what we can do is we can use the property, this property right here, a over b raised to minus m is equal to b over a raised to m. So basically we can flip the fraction so that we can lose the minus sign in the exponent. And that's exactly what I did here. You can see this, the second fraction here, it is 3 over 16. Now I flip it, it becomes 16 over 3. And notice what I do to the exponent. Minus 2/3 goes to, or becomes 2/3, just 2/3. And notice what we end up with. We end up with the first fraction raised to 2/3, the second fraction raised to 2/3. Okay. Now we can do more with this because the exponents are the same. Okay. Now, so what I do next, I use the product of powers. When you have one power here raised to the same powers as the other one, a to m times b raised to m, you can essentially take out the exponent and then just multiply a and b directly. In this way, we can simplify the fractions inside the bracket first and then worry about the exponents after. Okay, so that's what we do. You can see here there's a 3 here, there's a 3 here, and then there's a 2 here, but 16 also has a factor of 2, so I can cancel stuff. In this case, I cancel 3, so this 3 and this 3, I cancel them, and then I cancel the 2 here, I get 1, and then I cancel the 16, I divide 16 by 2, I get 8. Okay, so now the top becomes 1 times 8, so give me 8 here, and then the denominator gives 1 times root 2 times 1, and give me root 2. And then what I do next, I write 8 as 2 cubed. So going from this expression to this expression, I write 8 as 2 cubed. And then root 2, I write it as 2 raised to 1/2. Okay? So you can see now we're getting somewhere. Now next, I use the reciprocal rule. Remember 1 over a to the n. You can take it upstairs and become a to minus n. So the cost of taking it upstairs is that you gain a minus sign. Okay? So I'm okay with that. I can do that. So that's why now this 2, which is in the denominator, I will take it upstairs. Okay, with no penalty. So I take it upstairs. Now I get 2 raised to minus 1/2. You see I gain a minus sign here. And notice I have a 2 here, I have a 2 here. So the bases are the same. If the bases are the same, what do the rules say? The rules say you can add exponents. So I can add 3 plus minus 1/2. And that's what I do next. So I say 2 raised to 3 plus minus 1/2. And so that's what we get. We get 5 over 2. So 2 raised to 5 over 2. Remember the whole time we have this expression here, the 2/3, the 2/3, the 2/3 that we factored out in the beginning. It's still, it's still, it's still around. So we have to deal with it now. The good thing is the expression is simple enough, so now we can deal with the exponent. Now, dealing with the exponent, we use this property right here, a raised to m and then raised to n. What do? You write as a raised to m times n. So we multiply the exponents in this case, or what we call the power of powers. Okay, so a to the m is a power, but you're raising it to another power n. So basically, we multiply the powers, and that's what I do. So now, what is 5 over 2 times 2 over 3? So basically, I multiply the exponents here. 5 over 2 times 2/3. You can see now the 2's are going to cancel. So this 2 here will cancel with this 2. And what is left over will be 5 over 3. And that's what we have here. It's equal to 2 raised to 5 over 3. So essentially, that's this whole expression right here. It simplifies to this right here. Okay, so that's how you can simplify expressions like that. Okay, let's move on to example 2. Example 2. We can simplify this expression as follows. You can see here I have a bunch of things. I have constants. I have 4, 2, so those are constant. I have a's. In the numerator I have a cubed. In the denominator I have a raised to minus 1. In the numerator I have b raised to minus 2. In the denominator I have b raised to 4. It's very messy when you look at everything together like this. So what I do is I separate like terms and also constants. So that's what we do here. You see the 4 over 2, so that's a constant. And then all the a's together, all the b's together. You write them as quotients. So once you write them as quotients, it will allow us to use the quotient rule. Remember, the quotient rule says a raised to m divided by a raised to n is equal to a raised to m minus n. Because the bases are the same, you can just subtract the exponents, and that's what I do. So now you can see now I have a raised to 3, this 3 right here, minus 1. So I'm subtracting this minus 1 from this one. Okay. Now we do the exact same thing to b's. So in the numerator we have b raised to minus 2. Denominator we have b raised to 4. So now using the quotient rule right here, this becomes b raised to minus 2 minus 4. Okay, that's all about it. The only thing we have to do now is to simplify the bracket further, and that's what we do. So you can see here the two negative signs will cancel, so minus 1 becomes plus 1. That's why we have a raised to 3 plus 1. And of course, you know, when I divide 4 by 2, I get 2. And then the 2 will come along here. For the b's, is minus 2 minus 4. That will give me minus 6. Okay. So and then we have to just, you know, simplify the exponent for a further. And then now we have 2 raised to 4 b b raised to minus 6. Okay, so now the inside the bracket is simplified as much as possible. Now we can worry about the overall exponent too. And sure enough, that's what we do. So we distribute the 2 inside the bracket, and remember, everything inside the bracket will get the exponent. So we distribute the exponent. So now we get 2 squared. So 2 squared, we have a raised to 4 times 2. We have b raised to minus 6 times 2. Okay, so here we're using the power of powers here. When you have a to the m times n, it's the same as just, you know, taking a times m times n. So basically in here I am multiplying the exponent first. So once we do that, we get this. So 2 squared becomes 4. A raised to 4 times 2 gives a raised to 8. b raised to minus 6 times 2 gives b raised to minus 12. Okay, this is essentially the final answer, but I would like to go one more step. And that is using the reciprocal rule. Because I don't like the minus sign in the exponent for b here, I can take it downstairs. And then that way I can lose the minus sign. So a raised to minus n becomes 1 over a raised to n. So instead of b raised to minus 12, when I take it downstairs, I get b raised to 12. Okay, so that's this whole expression here reduces to this expression right here. Okay, now let's look at the last example. The last example, we have not 3, 8x squared times y raised to 5 divided by 3x raised to 5 y raised to minus 3, and then the entire fraction is raised to minus 1. What can we do here? So what we can do here is we can use the reciprocal rule, we can flip the fraction. Notice that in the numerator I have 8x squared y raised to 5, but now it is in the denominator. Similarly, the denominator is 3x raised to 5 y raised to minus 3, but now on the right hand side it's now upstairs. It's now the numerator. So that's that's the flexibility that you get with the reciprocal rule. And the cost of doing that is you have to multiply the exponent by minus 1. Okay, you flip the fraction, and then you multiply the exponent by minus 1. So this is the right hand side and the left hand side are essentially the same. I did not change the equation. Okay, so that's the one thing I will point out here while we're here. When you are manipulating equations, please do not change the equation. The stuff you do have to make sure that you do not change the equation. Don't introduce stuff that will this is more like a seesaw. If you have a seesaw, if I put something on the left hand side, I must put the exact same thing on the right hand side to make sure that my seesaw is still balanced. That's how equations work. So when I flip stuff like this, the cost is I also flip the sign of the exponent. That way I don't change the equation. Okay. So next, what do we do? Okay, sure enough, I just drop the exponent 1, because when I have a fraction like this, a over b raised to 1, it's the same as just writing it as a over b. Yeah, so that's what I do. I just drop the 1 there. The next, I separate terms. So I put all the constants together, I put all the x's together, I put all the y's together. That way, now these fractions here, I can use the quotient rule. And sure enough, so I use the quotient of powers. So now I subtract this 2 from 5, and then I subtract this 5 from minus 3. So now we have 3 over 8 times x raised to 5 minus 2 times y raised to minus 3 minus 5. Okay, next we simplify. So 5 minus 2 gives us 3, so we have x cubed. And then minus 3 minus 5 gives minus 8, so now we have y raised to minus 8. This is essentially the final answer, but I would like to take another step as well, or again, and that is just to convert this negative exponent to a positive one, and that is using the reciprocal rule. So the reciprocal rule, I take the y raised to 8 downstairs, and by doing so I lose the minus sign here. So now we have this whole expression here simplifying to 3x cubed over 8y raised to 8. Yeah, so that's how you solve problems using laws of exponents or indices. Remember, to be confident, you have to solve a lot of problems. You need to solve these small problems. Even when you take your exams, your speed will be determined by how many problems you solve. The more problems you solve, chances are you'll actually finish your exam faster and you'll make less mistakes. So make mistakes by doing practice, not when you're doing your exam. Okay? Thank you for watching.